talk a lot about trying to reduce the cost of access to space. Ariane yesterday was talking about operational reusability. We talk about trying to pull from the satellite side. Let's have more launches. We can reduce the cost due to quantity and the unit cost. We can spread out our fixed costs among more units. But another thing we don't talk about a whole lot is let's look at the manufacturing side and how we're making these parts. You know, how we're making these things is really decades and decades old. Sure, we're using CNC machines, but it's still mills. We're still taking blocks of metal and whittling away 90% of this material. And what additive manufacturing is bringing to us is a new way of thinking and evolving our designers and our machines, and allowing possibly, you know, huge percentages of reductions in costs. So what got me thinking about this machine within a machine was something that Elon Musk said at a shareholders meeting last year for Tesla, and he said, the true problem, the true difficulty, where the greatest potential lies is building the machine that makes the machine. In other words, building the factory. And what we have seen from the GEs, the people that are really investing in these, that are putting additive manufacturing machines into whole buildings where you just have one or two people operating them. So we're really investing hard in reducing the amount of labor in operations. So this is what I call my credibility slide. Why should you even listen to me? Who's Barber-Nichols? Barber-Nichols has been in business for 50 years, designing, developing, collaborating with partners for making specialty turbo machinery. And for the last 18 years, we've been doing rocket engine turbopumps. We started with a fast track turbopump with the NASA Marshall folks. We went on to do the first 50 turbopumps for the Merlin 1 for SpaceX. We worked with Lockheed, we worked with Aerojet. We're doing the turbopumps for the Newton 3 and Newton 4 engines for Virgin Orbit, and we thank them as a partner. We're also doing some additive manufacturing in collaboration with the United Launch Alliance for their really innovative integrated vehicle fluid system. And what you might take, one of the key takeaways here, and there'll be a few of them, is that becoming experienced in additive manufacturing is an evolution. You know, we talk about there's no room for failure. That's really what we want to try and do is say there's lots of room for improvement. And so you start off, when you're starting out with AM, you start off with, well, let's make something simple, because I'm worried. You know, this is a really complex machine. Let's start off with something simple. Then you start making more changes. You start saying, well, I'm going to take these 3 parts and I'm going to put all 3 parts together. I could make them normally and weld them all together. Let's try it out. And then you start getting into the real hard things like, well, I can't make this any other way. What if I grew the part? What does that look like? So there's a bit of an evolution there. So what I want to tell you is, yes, AM is useful for rocket engine turbopumps. This is a page from Greg Kennedy yesterday. I appreciate his insight on this. It does take several years. What we've seen is the companies that have invested in 2012, 2013 are the ones that they're seeing the most advanced parts come out. So when Aerojet talks about their injectors and you see the complexity, that took a long time to do. And so we are, you know, somewhere in the 3 to 4 to 5 range for Barber-Nichols. There is still plenty of room for growth and maturation in this technology. One of the things that Barber-Nichols brings to this discussion is we make specialty one-off custom machinery for everybody in every industry, in every application, in every environment. And they all trust us to do it right the first time. And so we're very considerate and conservative of, well, are all the processes in place? What does the complete supply chain from end to end look like? Can we say with confidence we understand every single part? So there's still a lot to grow, and I'll make a few points there. So what we wanted to do, we got some funding from Space Missile Command as part of the RD-180 Technology Maturation Program. And that was to see how far we could push additive manufacturing when it came to rocket engine turbopumps. Now, maybe 3 or 4 years ago. The guys at NASA Marshall were doing some work, and they presented at JANF in Nashville on a 30,000-pound LOX hydrogen turbopumps. And that sparked the idea, well, how far can we push it? So we got together with Northrop Grumman, and they said, well, here's a 300,000-pound LOX methane engine cycle. Can you make a turbopump from that? So based on that data, we started our design. We used our design methodology, and we looked at how would you make it traditionally and how would you make it using AM components. When we found out a few interesting things. First, AM development is great for this, build a little, fail a little, improve, building failure into your program management. It's very similar to software development programs. You guys are a lot of project managers, business people that are working on determining how much funding to apply to these things. Make sure that you're putting in some money for failure, for iterations. Make sure you're encouraging your project managers and your engineers to develop, when they develop their analysis tools, make it such that they can iterate multiple times. And because what's great about this is you can do your rough models early and provide them to your designers, for the ones that are building the parts, and your technicians that are putting them in the machines. And they can start doing the parallel processing. They can start actually making rough parts while you're finishing up your design. And you'll need to do that because you won't make your first part perfectly the first time. The complexity is free, but it takes a mindset to get there. And anybody can do it, but you have to learn to do it. Talking with Ken Davidian, he does plastic parts for people. He did, I think, these letters here. And he said it was multiple iterations just for plastics. So you have to give your engineers and everybody some time to evolve. And you'll see that if you give them the time to evolve it. If you don't have millions of dollars and can't invest in these machines like we didn't at the time, you have to go find vendors who can do it. So we went out to Stratasys. We went into Linear Mold AMS that's now owned by Moog. And we started working with them. And so some suppliers, vendors will have different experience levels. And what you'll find is you'll want to find that person that has the most experience level with the parts you want to make. And eventually you'll surpass them if you bring that capability in-house, because you're hyper-focused on your kinds of parts, your kinds of applications. They tend to be jack of all trades, master of none, and you're a master of what specifically you're doing. So be aware of that when you're planning your projects. Ultimately, what we want to try and do with the AM is remove as many operations as possible. Remove as much labor. You want to increase your unattended manufacturing. So meaning you want to have one person running 10 machines. You want to have one person running 6 mills. And so be aware that, again, the complexity is free in the labor costs. So this is where we're going, that I see the future for AM, is this factory that's nearly as automated as it can be, and that'll drive down your costs. It's the constant hands-on, the constant shipping and putting in a mill and taking it out and doing the next operation that's really driving the costs. So conclusions are, yes, we could make the LOX turbopump, LOX methane turbopump using the AM. However, size of the current build volumes are a limiting factor. We had to drop our overall theoretical performance to fit within the build volumes. Specifically, and for example, the build volumes of the EOS 400s around the 15-inch cube diameter or volume. And we wanted the turbine wheels, we wanted to be a little bit bigger to reach maximum. And we can always do it 2 stages if we need to, but you'll make it a consideration. What we estimated is that turbopumps and engines in the 200 to 250,000 pound thrust range are applicable for the current AM technology. Now, there's certainly other technologies out there. There's the DMG Mori machines that are doing blown powder, laser-centered, Concepts Laser that was recently purchased by GE, making much larger machines. But we found that the EOS can hit the precision, they're reliable, and from our point of view, when we're supplying parts to our competitors, we really were taking a more of a conservative role about that. Now, the cool part about this project is we had a ton of cost and schedule data for traditional machines, and so we could compare it. with designing it AM or designing it traditional. And we saw up to a 50% reduction in cost and lead time for AM. So there's definitely carrots there if you want to put the time in. But the whole supply chain is still evolving. The powder, the processing, post-processing, the inspection, and what you want to eventually try and do is get as much inspection out of the system and really lock down your processes. Once you do that, you can see real reductions in costs. So finally, in acknowledgement, I want to thank the Air Force Space Missile Command for funding this opportunity. We had some really great partners. Northrop Grumman was our prime on this. We partnered with Concepts NREC. And honestly, if you get an opportunity to partner, they're a competitor for us in many things, but driving and working with them drove us to succeed and be better. Checking their work, checking our work. We learned a few things from both sides, and it was a really great experience. Finally, I also want to thank the guys at NASA Marshall. Without their insight, we're basically standing on the shoulders of giants here, and we're pushing their work forward, so I want to thank them. Finally, also United Launch Alliance and Virgin for allowing us to speak all that briefly about their projects. A lot of this stuff is ITAR sensitive, NDA sensitive. We're a lot like Fight Club. You don't talk about Fight Club, or you don't talk about BNI or BNI's projects. But if there are questions you have, I'm happy to talk about them offside. Thanks.